Okay, for question 5, a vehicle of mass 1.8 ton has an engine which produces a constant power output of 90 kilowatt. We experience a resistance to motion of 36 V when moving at a speed of V. Okay, so resistance can change. Right. If D is the driving force and R is the resistance to the motion, write down the equation of the motion. So can form a net force equations. So A part 1. So driving force minus the resistance is equal to M A, right? So MA. And part 2, the power equation. So P equal to the power equal to FV, and for this type F is equal to D, so 90,000. Okay, is equal to dV, right? So the power equation. Okay, for B, use this to show that the equation of motion can be written in. Okay, for first one, you know that 90,000, okay, over V and minus 36V, P equals to FV, so F equals to P over V, and is equal to 1800. Okay, A you can change to dV dt directly, right? And you combine to the left hand side, you can combine, so 90,000 is equal to 1800 dV dt. Okay, so for the first equation. For the second equation, actually all the things are same. You just need to change the A to V dV dx. Let me remove the dV dt first. Okay, so change all the A to V dV dx. V dV dx. Right. So you will have the equation for part 2. 90,000 minus 36V over V is equal to 1,800V dV dx. Okay. So B part 2. Okay, for C, find the maximum possible speed of the vehicle. So as you know that at the maximum speed, A will be equal to 0. Right. So you can use either equation 1 or equation 2. So if you put A equal to 0, you will get that 90,000 6V is equal to 0. Okay. So if you want to define the equation, so V square will be equal to 90,000 36, right? Okay, if you proceed, you may get that V will be equal to square root of 90,000 over 36, and is equal to 50. Okay, so the maximum speed is equal to 50. Okay, let's proceed to the part D. Part D, use the separation of variable in equation or equation 1 and find the expression of t in terms of v. Okay, so we separate them first. Integrate of dv 90,000 minus 36v squared dv is equal to integrate of 1 over 1800 dt. Okay, so if you proceed to calculate this by using the skill in the integration, you may get this negative 1 over 72 90,000 minus 36v squared plus c, okay, is equal to t over 1800. Right, so you may have this equation. You may simplify, put t in terms of v. So t equal to negative 25 ln 90,000 minus 36v squared plus k. Okay. So when t equal to 0, v will be equal to 0 also. And you will get k equal to 25 ln 90,000. Okay. And put this equation back to the original equation, you will get t equal to 25 ln 90,000 over 90,000 minus 36v squared. Okay, so this is equation t in terms of v. You may have different formula, but must be t equal to what v, right? So this one for question D, part 1. Okay, for question D, part 2, right? So we need to put v squared in terms of t, right? So you may do that ln 90,000 so simplify, so 90,000 okay, so and proceed to simplify. Proceed to simplify, you will get 36, okay, over 36 over 90,000 v squared is equal to 1 minus e T over 25. Okay, and you will get v squared is equal to 2500 minus 1/36 e negative 25. Right, so this is the equation that required by the question. Right, part 2, D part 2. Okay, so for E, part 1, use the separation of variables and partial fraction to show that the integration of second equation leads to the equation below. Okay. Okay, so for part E, okay, for part E, same thing, separate them to two sides. You may have this integration, right? V square dv okay. So for the left hand side, you know that if you want to do the integration for the fractional form, the degree of the equation on top and below are same, so you need to do a long division to remove the constant first, right? Or you have any other way to refer the constant first, so you may get something like that. Okay, and the denominator you can factorize. Okay, dv, right, the left hand side. Okay, right hand side still the integrate of 1/1800 dx. Okay, so by continue to do the partial fraction at the left hand side, you should able to get the answer of the question that show in the part 1, right? Right, so you may proceed to calculate, see you can get the answer or not. This is the important part. Okay, first to remove the constant, then do the partial fraction. After the partial fraction, then you may proceed to do the to form the equation that the integrate equation that required by the question, right? So this one E1, E part 1. Okay, E part 2. You have a question asking you integrate both sides of this equation to find in terms of x. Okay, so one side, the right hand side are right in the left hand side, so negative 1250 ln 300 minus 6v plus 1250 ln 300 plus 6v minus 50v is equal to x plus c, right? So negative 1250 ln 300 minus 6v plus 1250 ln 300 plus 6v minus 50v is equal to x plus c, right? So simplify the equation. 1250 ln 300 plus 6v over 300 minus 6v minus 50v is equal to x plus c. Okay, so but apply the initial condition t equal to 0, and you know that at a starting point x equal to 0 and v equal to 0, you will get c equal to 0. So at the end you will get a equation x in terms of v 1250, something like that. Okay, okay, minus 50v. Okay, so this is the equation x in terms of v for part 2. Okay, C E part 2. Okay, for the last part, Okay, for the last part, question show that it takes approximation to reach V. So V equal to 330 and X will equal to 1250 ln 300 plus 180, 30, 300 minus 180 minus 150, right? So you will get X equal to 232.86, right? So it's almost is 233. So you prove the last part show that it takes approximate 2 to 3 meter for the vehicle to reach 30 meter per second for the rest, right? So this is for part 3. Okay, hope you can get the answer for question 5. Right.